All right, so now we're going to look at this thing, which is the equation of a line. And this you're going to have to know for a long time. It comes up for the next couple years, and you're going to continue hearing people say y equals mx plus c, y is equal to mx plus b, y is equal to mx plus some letter here. And it doesn't matter what you which letters you use. Eventually, what you're going to do is start applying models of lines, and so you're going to use something like volume is equal to, I don't know, A times T plus Q. So currently you're going to probably ask yourself, well, what does this mean? Don't worry, we're just going to use and understand how the equation of a line works. And once we know that, then we can move on to more advanced ideas and how it works with application questions. So if we look at this, we have this equation of a line, which is all these letters. Now, we want to make sure that we differentiate all the letters. We don't put them together. For example, if I were going to look at this and I was going to analyze every letter as fruit, the Y is like a banana, and the M is like an apple, and the X is like an orange, and the C is like, I don't know, a grape. So they're all very different. So if I ask you what the gradient is, you shouldn't give me both the M and the X. They're totally two separate things. Okay? Now, the M, the value in front of the X, is what they call the gradient, which we've already learned. And it'll tell you how the line is sloping. And we already know that, of course, if the M or the number in front of the X is positive, you should have a line that's leaning forward. And if the M is negative, you should have a line that's leaning back so far like this, okay? So put my little arrows here on my lines, meaning they go on forever, okay? So in this here, I know whatever the gradient is for this line, you could do rise over run and pick some points and try to figure it out. We know that this is going to be for sure positive, and this gradient here for sure is going to be negative. So how does this help us? Well, we have this form here, y equals mx plus c or mx plus b, whichever one you see in the books. And essentially, we already can tell how to plot this line much quicker than using the gradient intercept, or pardon me, the gradient formula and trying to find 2 points. And we did the table of values, if you remember, where I put in some values here, and we did this. And then I said, okay, what happens if x is 0, x is 1, x is 2? And you put it into this equation here, and you read off your values of y. Now, it's not so important. We don't have to go through this because, first of all, we know the gradient is the number in front of the x here. So in this case, the gradient is 1/2 for this line. And what else is important is the value of c, whatever this floating number is after the gradient in x, that's the y-intercept. So that's where it crosses here or here. So it's nice to know. So we already know by looking at this, generally this gradient intercept form, that my gradient is 1/2, and I cross that y is equal to 4. So that's nice. I can immediately, whenever I have this equation, I can always put a dot where I see my y-intercept, which is 4. And then now you can count your squares in this case if you want, if there's a grid, and you can do your rise over run. So for example, if I have this at y, my gradient is 1/2. So remember, the top number is the rise, and the bottom number is the run. So it says for every 1 I rise, I run 2. So starting from this point 4, which I choose because I have my y-intercept now, that's my value of c, I can rise 1, 1, and I can run 2, 1, 2, and then I can put a point. And then I can rise again 1 and run 2, 1, 2, and put another point. So all I'm doing is counting 1 up and then 2 forward, and I continue putting points from my y-intercept, all right? And of course, we can go backwards. We can run backwards 1, or pardon me, run backwards down 1 and 2 backwards here. So if they're both positive, we can go forward and up. And then if we want to switch directions, we have to make them both negative, which is to go back and down. We discussed this and we worked on this before in the class last week. And now all I need to do is I can take my line and I can try and draw and connect my points here. Let's see if I can connect them. So this line here represents this y is equal to 1/2 x plus 4. So it has a y-intercept of 4 and a gradient of 1/2. That's what I've done here. So the gradient intercept form is very helpful because we can sketch ideas and we know exactly where they cross our y-intercept, or our y-axis here. So this is the y-axis, remember, and this is our x. Okay, so that's very helpful. So if you look at these equations, or these equations that I have here, it says state the gradient for the following linear equations. Okay, so now my gradient is the value in front of the x, so my gradient is 2. So my m is 2. In this one here, my value in front of the x is -4. So m is equal to -4. In this example, my gradient in front of the x is -7/4. Okay, and then this one is a little bit more tricky because the 8 is on both, or is underneath both of these values. So what you could do is you can separate them so that the common denominator on both of them is 8. Well, that's a little bit of trickery that we can do. So you always can separate values if it's over top of one number here, so 8. So now I can figure out what my gradient is. Well, it's simple. It's the value in front of x, which is 4/8, which is 1/2. Now be careful. I know people are going to get this mixed up. If I have a gradient of 1/2 and the x is here, it's obvious that the number in front of the x is, well, 1/2. But I can also write this as x/2. And so you're wondering, well, what's the gradient? Well, it's not 2 because there's this hidden 1 in front, right? So when you have a fraction, you have to be careful that you make sure you understand what the gradient is. If there's a number in the denominator, you have to make sure you take this hidden 1 and apply it so that we have 1/2 in this case. So these two things are the same. They're just written differently. So that's our gradient intercept form. That's one form in which we write down lines, okay? So then there's some questions in the book for you to work on there. Now the second form is called the general form, okay? And the general form looks kind of like this. It's really strange. It has ax plus by is equal to c. And in the general form, you cannot tell what the y-intercept is or the gradient. It's in a form where we've mixed everything up and it's no longer in the gradient intercept form. So if I give you the general form and I ask you to find the gradient or the intercept, you have to move these things around and change it back into the gradient intercept form. So let's take a look here. In this example, we want to note important that in the general form, the coefficient of the x term is usually positive. So the value of a should be positive when we move these around, okay? The second thing we want is that a, b, and c are not fractions. So I'm going to show you an example on how to make sure that doesn't work. So let's go ahead and convert these below. So if you look below here, you can see that these are in the gradient intercept form. Here's my gradient 2 and my intercept 4, right? Here my gradient is, well, we have a hidden 1, so we have -1 and -1/2. And my gradient for this one is 4/3, and my y-intercept is -1/2. So this is all in gradient intercept form. And what I would like to do is change it to this bizarre general form. So as you can see for the general form, the ax and the by are on the same side. So if I want to move this around, I should have my y moved over onto this side. Okay, so if I do that, I'm going to have 2x minus y. All right, and this c is the value of the number that does not have an x or a y. The coefficient is not in front of the x and y. So this c here, if I want to move it onto the other side so that it's not on the same side as the terms of x and y, I'm going to rainbow that guy over here, and I'm going to have -4 in this case is equal to 2x minus y. So I'll write this a little bit better. -4 is equal to 2x minus y. And now I check my conditions. The coefficient of the x term is positive. It is. Look, +2. And a, b, and c are not fractions. Look, -4 is my c. My a is my 2, and The number in front of my y is the b is -1. So I can fill this in. So a is 2, b is -1. It's associated with the y term. And my c on the other side in this case is -4. So we have this here. Okay? So that's what we're trying to do. It's quite simple. All we need to decide is, should we move the x onto this side here, or should we move the y onto this side here? So in this example, you can see the value of -x is negative, and I want it to be positive. So the best thing I should do is rainbow that over. So I have y is equal to, or pardon me, y plus x is equal to -1/2. And now what I want to do is get rid of these fractions. So if I multiply this whole equation by 2, everywhere in here, in here, and in here, well, 2 times -1/2 gives me -1, so I get rid of my fraction. 2 times x is 2x, and 2 times y is 2y. So ta-da! I have a positive x term, and I've gotten rid of fractions. So now we can write the values of a. So the a is the number in front of the x, so it's 2. The b is the number in front of the y, which is also 2. And c is the number on the other side here with no x and y terms, so this is -1. So we have those there. So if you want, you can try this on your own. This next question, you can pause the video and give it a try. If not, I'm going to go through it here, and you can continue watching the video. So I'm just going to move it outside the box so I have a little bit more room here. So what I'll do, make it easier for me, grab that here, and I'll move it over here, okay? So first of all, the coefficient of the x term is usually positive. If you want to get rid of the fractions first, you can, but I usually move this around so it's in this form: ax plus by is equal to c. So if this is the case, I notice that this is positive, which is good, so that would mean that I would have to put my y over there, so the value in front of the x stays nice and positive. So I have that. And I want my c on the other side, so if that's the case, I'm going to throw this -1/2 over here, and I get +1/2. So already it's starting to look like my ax plus by is equal to c. If you don't like it in this form, what you could also do is just rearrange it, so you have 4/3 over x minus y, and you put the 1/2 on this side. These two things here are the same. Okay? Now this really looks like this: ax plus by is equal to c. Notice how they sort of link a little bit better. This here is together, these two here are together, and then these here two are together. And now I want to get rid of these fractions, because nobody wants fractions in this general form. So how do I get rid of the 3 and the 2 in the fraction? Well, we find a common denominator between 2 and 3. And if you find a common denominator between 2 and 3, you'll notice that it's 6. So you need to find the common denominator, and that's the easiest way to do it. So, and if you're wondering why, if I multiply this number, or this equation, I'll use this one here. I'll rewrite it so it's a little bit nicer. So 1/2. If I multiply everything by this common denominator like so, in here, and in here, you will realize that you get rid of the fraction. So if I put a 6 there, 6 divided by 2 is 3. If I put a 6 there, I have -6y. And if I multiply 6 there, 6 divided by 3, these will cancel out, so you have a 2 there still. So 2 times 4 is 8x. So now I finally have my form that I've been looking for, which is ax plus by is equal to c. And my a in this case is 8. My b is -6. And my c is 3. So there we have it. That's how we change from the gradient intercept form into the general form. One last idea is if I give you something in the general form, let's say 4x plus 6y is equal to, let's say, 3, and I ask you to change this into the gradient intercept form, which is y is equal to mx plus c, it's very simple. All you need to do is isolate for your y. So the first thing I would do, because I want y to be by itself, is throw this 4x onto this side. So I have 6y is equal to negative 4x plus 3. And finally, we divide by 6 on both sides, like so. So now you will see that I have negative 4 over 6, which is negative 2/3 if we reduce it. And we have 3 over 6, which is 1/2. And now I can write down what the gradient is, negative 2/3. And I can write down what the y-intercept is, b or c. Sometimes we use different letters. I'll use c because that's what I use in the presentation. C is equal to 1/2. There we have it. All right, so please let me know if you have any questions, and send me a message and I can give you a hand. Work on the homework that I put up on École Direct.